So this is the problem we are solving currently. So in this problem we have given an integer x, and we have to basically we have given an integer and we have to find two of the minimum possible uh, like minimum possible value of any two value a and b, and where LCM of that a and b will be that integer which we are given, and that a and b should be close to each other. So you can think of this as how we are solving this as normal. Like if we take an example of 6 where it has 1 2 3 and 6 uh, as in 2 as an full set of integers, if we take as an array. So if we take this as a 1, so we will get another as 6, so 1 and 6 will be, so we have to minimize this maximum value of a and b. So if we take any integer from 1 or from the start, it doesn't give us as a maximum value, because we have to take this region values more than the far away from the middle values. So we have to take from this indexes, like the middle one indexes. We can say like n by 2 minus 1 factor or indexes. So we have two possible. So what we can think of it as, like we have one number theory property is that any two multiplication of number is equals to LCM of that numbers and into GCD of that number. So we have given, let's take LCM as x, we have given, and GCD as this and this. So we have to minimize this maximum value of a and b. So we have to choose close to each other. So it means they will be close to root of x, because if you see any value like 6 or you can say 9, the root of 9 is 3. So if we take 3 one of uh, as a number, and as a, the other will be 3 as b. So this will give us minimum of that max value. So it will give. So this is an optimal case, because if we take any other numbers like 9, other value will be 2. Other value, like if we take any other number like 18 and it has 9 into 2 as that, or 3 into 6. So there are very many possibilities, but if we take root of n, which is approximately close to which number, it is going to be close to 4 or like that. So which number is going to be close to that, which divides that 18, it is going to be our answer for that. So we can use this property. So if we simplify this to x equals to a into b, and we can divide this by GCD. So let that p, we know that a is going to be one of the, and the second will be going to be x by a. So we will put this in the equation for that, and we will get this equation as end of the day. So we have to get this GCD value as 1. To get the GCD value, so we can iterate through root of x to till 1 to get which GCD will we get as a divided by a by x equals to 1. So this will give us a solution for this problem.
This is the code we have written. So it has a GCD function with long input, like a custom GCD function. This is a normal GCD function we have. So after this, we will just take a test input, since we are going to be testing at only one input. So we are going to be using t equals to 1 here. So in the solve function, as we are going to set the limit as a square root, like we are going to take this limit as square root of n. We can also use some other optimization here, but it is not required as it is accepted. And we will just iterate through this limit, starting from this limit root x, the root x to 1, because we are iterating to the divisor of that for that. So we will iterate through it, and we are going to get a pretty much like a dry like case, like how we are going to be finding the disability of that row. So if it is visible, we will find like a like the GCD of this, both like the I and the N of I can directly pass from here. But if you want to store, you can also store the temporary, because uh, you will require this to swap this too. So if the GCD is 1, because we want that to be 1, from here the function will, if it is 1 or not. And after that, we have found that number because we are iterating to this point, which like this this is a number line, and this point to this point we have found this. So this is going to be given us like a uh, like that point where like the we will get A and B to be the minimum of the maximum of A and B. So we'll just print it out from here.